So welcome to the Show Us Your Project session. In case you haven't attended one before, this is a session where slides are strictly forbidden. And the only thing we want to see is your Snap screen showing us one of your Snap projects. Okay, you have 3 minutes to do that. You can decide to present anytime. Like if you have a project now that you would like to show, just say so in the chat, and I will add you to my list here. And that's all. 2 minutes, you will hear a pretty annoying sound reminding you that you have just 1 minute left. And at 3 minutes, you will hear an incredibly annoying sound reminding you that you should stop presenting. And with that said, Yuan and Dan, stage is yours.
Thank you very much.
And you'll have
all right.
Here.
So this is the second continuation of the JavaScript graphics library. The block that we have written is to set the line dash style. So what this does is it takes an input of a list, be it an empty list, which would draw a non-segmented line, or lists with different numbers in them. So we have an example here. So if you had a list of 10, it would give a segment of 10 that has been drawn, and then a space of 10, and then another segment of pen down of 10. So, but that's just one line dash. So then this would be a list of 20. So this would be a dash of 20, and then a space of 20, and then a dash of 20. This is a space of 20, and this is a list of 20 and 10. So it would be a list of a dash of 20, a space of 10, and then a dash of 20 again. And then for the third...
You want to show it now?
Mm-hmm. So as you can see, this would be the dash of 20, the space of 20, and then the dash of 20 again. For the 2010, this would be the dash of 20, the space of 10, and then the dash of 20. For 20, 10, and 100, it becomes a little bit more complex because it goes dash of 20, space of 10, dash of 100, space of 20, dash of 10, space of 100, and then that'll repeat itself. And let it be known that each iteration is only one, right? And we have a loop here, but it is just one iteration of 20, 10, and 100. And this 20, 10, 150 is space of 20, dash of 20, space of 10, dash of 100, space of 50, and then it goes on. And then this is dash of 20, space of 10. Oof. Dash of 20, space of 10, dash of 100, space of 50, dash of 25, and space of 20, and then I'll go on. So, yeah. And the way this was made was just running the JavaScript graphics library, just applying it to Snap. Thank you very much.
Thank you, Yuan. This was really good. I actually didn't know that you could do that with the primitive canvas function. Okay, so
we together humbly contribute this to be able to possibly be added to the working set of libraries that other folks can use, in addition to the ones we made last year.
But couldn't you have written this purely in Snap?
Yes, well, totally. He could have written in Snap. The fun thing is, that's true, and JavaScript extensions has to be on for it, but the fun thing is, each of those lines is just a single line. So there's not like a do this, do this, do this, like where I pen down, pen up. But you're exactly right, Ken. It could be pen down, pen up. What this does is, it's true. That's true. You certainly could have written this purely in Snap with just pen down and pen up. It was just, it's faster. Maybe it's faster, I don't know, arguably. But each of those horizontal things is just one line. It's like, pen down, move 400, and it creates that beautiful line dash pattern. So it's not like I had to do that. In Snap, you would have been doing that. But here it's just pen down and move to the right side and pen up, and it does that beautiful pattern for the dash line.
Yeah, Simon is right. He's telling us off because we're supposed to be quick. So it's now time for Michael. Michael, are you ready? Michael Broll?
Yeah, I can I can go. Actually, yes. All right. So someone want to manage the screen sharing or stuff while I am pulling this up. So what? Actually, let me really quick switch the window so that we have just this. So I was going to demo a quick sort of work in progress project of using the new blocks in Snap 7 to do some basic sort of code analysis on a project. So this is something that you might use as an instructor to give to students. But what's really cool is that one of the blocks we have is this thing called my scripts, and it returns a list of all the scripts inside of the current sprite. And inside Snap, we have a bunch of other blocks. One that you may have used in a couple libraries, but the one that I'm using right now is this primitive block called data group by, which is a higher order function that takes a list and a function in which you can group things. And so what I can do, I can write a thing that takes my blocks, looks for just the stuff in the syntax tree that are actually blocks, and I can group it by their block category. And so this tells me that this script right here has 19 list blocks, 17 other blocks, most of which are the is a block or the data group by, and so on. And then I can do things like saying most of these things are reporters. There's only one command and a few predicates. But what I can also do, because this is Snap 7, or excuse me, this is Snap 8, is I can give myself a script pick of this. Then I can go to another project. I can drop this script pick right in here. And because I grabbed the background, I got the entire sprite. But what's actually going to be easiest here is if you want to do this with one script or one sprite, you would just drop it. And now we have a moderately reusable way of inspecting and presenting code in other projects. Obviously, we should change this from just my scripts to other things, but that's the start of code analysis with Snap 8.
Nice. Thank you, Michael. So yeah, with Snap 8, you can start actually building your own tooling in Snap. And as Simon is reminding us, please remember to drop links to your projects in the chat so we can add them to the SnapCon collection. And next up is Ken Khan. Ken, are you around?
Yeah. So let me share the screen. Let's see. Must be this one. Share scene. And here it is. I don't know. Get rid of that. All right. So if I start this up.
Who do you want to talk to?
Eve.
Which engine?
Da Vinci.
Okay, Da Vinci. I'm Eve. Ask me anything.
How tall are you?
I am 29,029 feet tall.
What's that in meters?
I am 8,848 meters tall.
Do you have any neighbors?
I do have some neighbors. Lhotse, Nuptse, and Pumori are all very close by. They are all beautiful mountains, and I am very proud to have them as my neighbors.
What should I do if I want to climb you?
If you want to play games, I would recommend going to the Thamel district in Kathmandu. There are lots of shops there that sell all sorts of games.
So that was the voice recognition thought I said play. The important thing here is you can not. I made 4 different personas, and some of them are very easy, like Charles Darwin. Oh, I should say this is working by talking to GPT-3, and this whole demo is probably going to cost me a penny or two because they do charge you. So every persona has something like this that sort of sets it up, saying that you're an intelligent agent pretending to be, say, Charles Darwin, and you're really helpful and stuff. And then just a couple examples. And then the program does is whatever you say, it will be prompted by the concatenation of those two things and what you said. And this part here is a rolling thing. So after a while, it forgets the earlier part of the conversation. But I think that the fact that, you could talk to an elephant, you could talk to Charles Darwin, but maybe most important, a kid could make one of these prompts and talk to, their favorite dinosaur or whatever. It has to be something that GPT-3 would know about. So it has to be something that, is likely to be in Wikipedia and other books and articles, but it's a lot of fun to play with. It's not perfect, of course. Sometimes it'll say silly things, but as a fun thing and as maybe an educational thing, I think there's some potential here. So I'll put the link in the chat and I'll stop sharing.
Thank you, Ken. That was brilliant. I'll look into the project later, but I was impressed that it's keeping context. So you can actually continue the conversation, not start over all the time. Okay, next up is Joachim. And please remember, if you have a project that you want to show, let us know in the chat and I will add you to the list. Okay, 1 second. Yeah. Okay.
Okay, now you can see my screen.
Mm-hmm.
Okay, I recently wanted to create some population biology models, which I used decades ago, and this time, of course, in Snap. My first example is the simplest model, the logistic growth, like the growth of a bacterial culture. If you open, you can see here the equation of the differential model. So that's nothing special, but I wanted to change the equations and to have a library of population biology models. So how could I do that easily? So I tried to make a routine just to exchange them. Here is a second model, the famous predator-prey model, and it's sufficient to exchange the equations and to set numerical values for the parameters. I do the equations in rings, and afterwards it's calculated in this routine. And here you find the equations, and it doesn't matter how many equations, how many parameters, that's just defined in that block, and you call that block in calculate equations, that's it. So in my small system, it's now sufficient to reformulate the equations and so on. My short-term goal is to have a library of population biology models. A long-term goal would be to have a kind of graphical modeling system. Maybe you remember Stella. I made one for pharmacokinetic models, and it looked like that. There you have a stage where you can put together the symbols and for the numerical values, and then you can do the simulation already. Thank you.
Thank you, Joachim. Could you also drop a link to your project? I'd really like to.
Yes. I'll do.
And I think Yuan didn't send me the link. So if you could do that, please, too.
It's already in the conference app, too.
Oh, okay, I see. So next up should be Brian Broll.
Hello, one moment.
Okay, Russel, I've added you to the list.
I'm going to start sharing my screen. So I'm watching the little ones right now too, hence the screen otherwise being off. So everyone hear me?
Yep.
Yep.
All right. So let me jump right in. So one of the projects I'm going to show today is this one. Hi, Charlie. Okay, so basically this is an introduction to generative adversarial model training. So like in this case, we have this project where we're training a discriminator and a generator. All of this is done in NetsBlox, so no embedded JavaScript library or anything. It's using this automatic differentiation library that I talked about if you saw my talk earlier. I forgot to start my. Basically, this is a project where, as this thing just described, we hit space to start. We create some positive points. And then we can click to train the generator. And right now the points that the generator have are way off. But then we've got this discriminator as well, which is this circle. So basically what we have is we have a circle that's trying to circle these green points. And there are some red points that are way off right now. And I think off the stage. So if I just alternate back and forth between training the generator and discriminator, we'll see that this circle, I don't know, 1 second here. Should see, 1 second, that generator should be training now. So let's see where, so okay, so I should have run this right before. Okay, 1 second, let me just try something again. I'm sorry guys for the ammo in the background. Okay, well, so 1 minute left. Basically, there are this example isn't. Here we go. Make some positive points there. Now you can see those red points in the top. Those are the negative examples by the randomly initialized generator. So if I train, so if I click to train the generator, we'll see those points start moving to the center of the circle. The circle is our discriminator trying to circle the green points and not the red points. Now I alternate between training the discriminator and the generator. So now when I actually go through and train the generator itself, which is taking a minute to redraw, but we'll start to see that it'll start moving down to circle the green points and not the red points. So it's kind of a hands-on activity. Thank you, Randy. Watching parents trying to Zoom with their young ones never gets old. So, the demo is but I do have to and I'll post it in the chat. I have but basically, it's a simple example. I'm going to stop there. If people have questions, post them in the chat. I'll post the link, things like that. So, so if you have any questions, you can jump in.
Thank you, Ryan. You did a fantastic job given the circumstances.
Thanks.
I have 2 assistants like yours, and I know what I'm talking about.
Yes.
Okay, next up is Dan Garcia. All right, and you can also let the person know who's on deck, maybe who's next, so they can get ready. Let me just here.
Yeah, since we have quite a lot of time, I'm not doing that, so
okay. Sure.
We're not in such a hurry.
Sure. I'll let you know when you start.
Yep.
All right. Welcome, everybody. I've always been a fan of 3D views of things, of the isometric view of a square, of a cube. If you see the isometric view of a cube, it's like when you look through from one corner down to the other corner, and so the square actually looks like 3 different rhombi all connected at the center. It looks. Many games play an isometric projection. So here's a data, just a data file. It's very simple. It's just a 2D array. I'm a big fan of basketball in the States, and this is the NBA Finals game. There were 6 games. So this is the first row is the number of games. These are the players, the key players. on the Golden State Warriors, who recently won the championship. And these are the number of 3-pointers that they made. Okay, so this is a little table. I'd like to see this in some way. And how would you view this, right? Most people, you've got a 1D plot, so you can see these things on a curve, and we just saw that in a previous one where you saw population growth, but you don't see this in 2D. So I want to be able to see this in 3D. So what I did was I created 3D graph initialize, sets up some things. This is all you need to do. 3D graph easy. Take data, you put labels on the two things. One is the game number, one is the players on that. And the 3-pointers made is what's in the content. So that's it, that's all you need. Then all I'm doing some fun stuff. I change the pen color and I make a left wall. So I actually draw on a wall, which is kind of cool. And then I draw on the right wall. And I'm just gonna run this. Bloop, bloop. And so what you're seeing is this graph shown in 3D where the text is actually written with a skew angle. So it looks like it's written on the wall. Then this text is written on the wall. You feel free to read this if you enjoy. This text looks like it's written on the floor, and it's actually correct. Like it isn't just, well, I try to skew it to, this is literally exactly how it would be if I were to write this on a physical thing and then tilt the camera so that you're looking down the center of that. What I decided to add, so these are little cubelets that I've wrote, and this is the kind of example of the cube where it's a little 3 different rhombi. And on the top of each cube is the data, is the actual value of the data. And so some fun things to look at this particular data set is number one, how many 3-pointers Steph Curry hit. He's this amazing 3-point shooter, and he's the first player to ever hit 4 consecutive games, 5 or more 3-pointers in 4 consecutive games, 7, 5, 6, 7. Also the fact that the Warriors won game 5 and they shot almost no 3-pointers, so they shot only 5 and 3. It does help as a thing to have a different number of rows and columns, because then they don't overlap. See how these don't overlap? If they actually were the same number of rows and columns, these would have overlapped and it doesn't look so good. So just a little bit of a caveat emptor, and this tells you what that is in 3-pointer, and I put a little dash line, and every single part of this can be customized. So you can change the color of the thin wall, of this, or that, or this, or this. And I'm done.
Dan, we should have a 3D collection just for you to fill up.
It's sweet.
I wish I could be your student. Go back to school.
And I'll put it in the chat.
Okay. Thank you. Next up is Jens.
Okay, can you hear me? I'm going to share my screen.
We can.
So, can you hear me?
Yep, we can.
So wait, this is the wrong project. I'm going to show 2 projects. So for a while, I'm going to show something about 3D. 3D was all the rage on the forum, and I was really not interested in those 3D projects from kids because I thought they'd been using JavaScript. They were just so good and so fast and so responsive until my friend Bernat explained to me how they are actually made. So the kids kind of slice the things they want to draw into slices, and then they just draw each plane and move the sprite a little bit. So what you get is this, and once you have this and you draw it very fast, you can actually turn it, and you can just apply the usual things, like you can make it bigger, and while you're turning it, you can make it smaller. It's just a fake 3D rendition. I thought this was pretty cool. And then this morning, as the girls for the workshop here didn't show up, I thought, what if I tried something else with this? What if I took a video of myself? I love playing with video, and I'd slice the video by the brightness. And so I'm making a couple of planes here. And what if I then, only made the parts of the video of each slice that is above a certain threshold solid, and the rest transparent. And if I overlay these, I kind of get this posterize effect. And I thought, well, what happens if I then apply the same trick that the kids do, and with every slice, I kind of draw it at a slightly offset thing. And I'm getting this embossing thing, which is kind of amazing as I did this. And basically now I have this running, and I thought, well, what, if I make a lot of more slices? What if I do, how about 16 slices? I get even more. It's like a Lego thing, and I might want to reduce kind of, you know, how much I do them. And I get kind of this amazing art-like thing. And by the way, I'm just using hyperblocks for all of this. Thank you, Wanda.
I mean, between that and you've rendered my project that I was going to show now boring. Okay, so it is now my turn. So I'll start my timer. I'll share my screen. And I'll show you a very boring 3D thing that I made. Can you see my screen?
Yeah.
So taking on this exact idea that Jens was explaining, where you take an object, you slice it, and then you make costumes and stack them one over the other. The other day I was looking at this demo scene projects where they render 3D spheres, and they did that in very old hardware, very non-powerful. And you have to use some maths to do that. And I was thinking you could actually do that by using this exact technique of just rendering one layer of dots over the other one. And you could actually create these layers in Snap by making a ring. So I made this, where is it? This ring maker, where you make a circle of a radius. So this thing gives you, if I say, give me a 12, oops, where am I? 12 steps circle of radius 100, I get, you can't see that. You can see that, why can't you see that? Is the pen not down or something? No, the pen is down.
Color?
I don't know why you can't see that, but it makes a circle of dots, okay? So what I did is I stacked them all and I made them turn, and there you go. You have a fake 3D sphere that's pretty fast and pretty easy. You don't have to know any maths to make it. And I think I'm done. Oh, well, you can change the amount of rings since I have a lot of time. You can change its density and make different sorts of 3D-ish spheres. My pen color is too light? Oh, you mean when I was making the rings? Yeah. Okay. So next up is Matthias Giger.
Yes. I will bring you to the 2D world from a former time and show you some old games. Can you see my screen?
Yep.
Yes.
Okay, so I'm working on a Moodle course, programming the Adafruit clue, which is somehow similar to the microbit. If you don't know the thing, that's it. It's got a lot of sensors, and the most important thing, it has got a nice little screen, like the games I used to play when I was a teenager. So there are some projects, like here, it just simulates dice. Then we've got something more advanced. I don't know whether you can see that, but I will try. Here it is. So you can here have some colors, and then you got the multiple choice question where you have to pick the right one, and if you do it correctly, then it will tell you that you've got it and you get some points. And then there are some more elaborate stuff like Snake, which I've programmed. That's the first version I did some half year ago. I tested it with classes. That's just a falling stone game. And I wasn't quite happy with it. So what I do now, it looks like this. We've got some instructions in steps. Then you need see the blocks you need for your program. And in H5P, you can do stuff like this, where you get some explanations for each block and some tips how you can program it. Then they can make their programs, upload it, and there's a solution for the teacher. And in this case, also some extra information and a simulation to do the music. And actually, the way I write it, I use some kind of macros to do these design elements. You can see that. And the last thing I'm going to show you is a blocky, a Flappy Bird clone, which is a bit more elaborate. So it works exactly the same. We've got here the explanations again. You can also include pictures or even videos into these explanations. Because that's a bit more complicated, you have some more steps. So that's basically it, the stand of work I'm now. And if you have time later on and want to give some feedback, especially what I could make better, please go ahead.
Thank you, Matthias. I forgot to set the timer up, but I think you stood right in time. I will have questions, but I'll send them to you later. So we only have 2 more projects lined up, unless Wachuku showed up. I think he didn't show up yet. So next up is Russel. Okay, Michael has 1 more, so we have 3 more people. So Russel, are you ready?
More if people need another one or want to see another thing.
I've got everything ready.
That sounded like Brian Broll who spoke.
Oh, Brian, you're one of the 3 people.
Oh, okay, cool.
Can people hear me?
Yep.
Okay. Where's the? Yes. Okay, so last year I made a 3D renderer using raycasting, and it was very slow. So I decided to try to recreate something closer to Doom or Hexen. Now, that's not finished, but there's some interesting challenges just getting the archives to work. So I thought I'd demonstrate some of that. So an archive, it has a header, it has a directory, which is at the bottom, and then it has in the middle a series of lumps. So the most important block actually is this thing. That's the most basic. It takes a string and converts it in Little Endian form to a number, and then a table which takes various tables or arrays of structs, as it would be in C, and converts them to just lists. Like this one gets the directory. So it extracts the part of the file that's directory, but as a string, and then it uses table mode 440 to turn it into lists. So 4 means int and 0 means string. So that part actually still takes a while, but there's also something like this, where you have a list of all the lumps in the file. And this is the shareware version of Doom converted to Hexen format with a different tool that's unrelated to Snap. From there, I can load things into, I can load each map into a different variable, like this one, which is going to have a huge array of stuff, which are going to be the things, line defs, side defs, vertices, sectors, subsectors, segments, nodes, or something like that, and block map. And then each of these is a table of itself. So that is one of the objects. I don't actually know how to read this, which is why I have blocks that I made with the programmatic editing thing for it. But that's pretty much everything.
Nice, Russell. I'm looking forward for next year where you actually render these levels.
Yeah, I might get it for Snapshot. I'm not sure about that though. It's surprisingly complicated.
Yeah, I know. Okay. So next up is Brian Broll.
All right. We'll see how it goes this time. So stop. Thanks everyone for your patience. Standing with my assistant. He's hasn't gotten started yet on Snap, but you know, maybe soon. We'll see. Anyway, so one of the things I was going to show now, I'm going to try to quickly show two projects. The first one is this project where basically you step into the shoes of there's an invisible function here, and you want to find the minimum. When you click, it gives you an arrow in the direction of the function. So I found this minimum here. And then you can continue doing this with more advanced functions. The idea here is to step in the shoes of a machine learning training algorithm. In other words, specifically gradient descent. So you can kind of build some of your intuition before we get into more involved examples. So after showing something like this, then we can ask questions like, what would it mean if this function represented different things? To a minimum. See if we find the actual one. So, you know, like what if this function represented, you know, number of followers or a number of viewers on your Twitch account or airline prices or things like that? And then what would it mean to find the minimum? And then once we've done that, then you can introduce things like machine learning with things like this, where we first generate so that we have some data points that we want to learn, and we start from some random location, and then we just do the mean squared error, and then just try to minimize this with respect to the slope and y-intercept here. And you can see this gradient is where the line started, and you can watch as it starts to minimize its error or tweak its slope and its y-intercept until it actually learns the function that generated the points. All right, so how'd I do for time on this one?
You still have the time.
Perfect. Whew, good, man. I was nervous. I was trying to account for interruptions and things like that. But I have more involved examples and things like that. But I just figured I would start with something simple. All this is using the same internals, where the actually I can just show that part too. But all this is using the same internals, so no JavaScript libraries or things like that. Just the function is just and you have PyTorch-like blocks for getting the gradient and stuff. Anyway, thanks for your time, and hope you guys enjoyed it.
Nice. Thank you, Brian. And thanks to your assistants.
Yeah, I'll pass them the message. Say thank you.
Okay, so next up, we should have Michael, but he's still finishing up the touches to his project. So Jens it is.
Okay. Okay, I'm going to share something which I hope I haven't shared before. That I didn't do this morning. So a while ago, my friend Bernat and I have been obsessing over Perlin noise because Joachim had been requesting that we add a Perlin noise primitive, and we didn't know how it worked until we somehow kind of found out how it does work. And so what this project is, it tries to actually compute the whole thing. So it makes a list, it kind of stretches the list, and then interpolates each kind of random value, and then it graphs it, and it kind of makes several layers. But you know, what I really want to show you is that through all this math, which is kind of, you know, boring, what comes out of it is you can have these layers and do some tricks with it and just render them over each other and move them at different speeds. And so each layer is recomputed. It's not just sprites, and you know, and the speed with which each of these lists wraps is determined by the distance to the mouse. And so I'm getting the Perlin noise terrain massive of layers of mountains, and I can kind of simulate a train ride. And every time I click on this, I get a new range of mountains. Kind of that is, yeah, just a bunch of numbers. Okay.
Thank you, Jens. I had seen this project, but it never gets old. Okay, if you guys could be not so fast, because you're taking just half of the time.
I'll just show
So
the project.
is Ugo Chuku in the call now? No,
I've got
okay,
another
so
one.
yeah, you're in the list.
Oh.
So Michael is up unless he's not ready, and then it would be Ken.
I can go. All right.
Okay.
So let me do that. And I've discovered some bugs with either Safari and New Snap. So this is a project that I've been playing with to teach things like image convolution. So how you sort of blur, manipulate images as a series of matrices. And what I find fun about this is that we can take some tricky concepts and make it pretty easy. But also, when you start thinking about things as hyperblocks, how fast operations in Snap are. So a pixel in Snap we can nicely visualize as just one sort of location in an image. And what's pretty cool is that when we work on manipulating images, we work on these things in sort of 3x3 different kind of blocks. So one of the things that blurring is you take, there's a bunch of different ways you can do this, but you basically take this grid of 3 pixels, you take all those values and you smash them back down into one value. So that's sort of like an average blur, as we say, each pixel is an average of the other pixels. And so with hyperblocks, we can do this really easily in Snap, where we start selecting images, selecting locations of lists that represent pixels in an image. And so the nice thing is that with hyperblocks, one thing to make this a little bit faster is I just compute all of these surrounding locations for each given pixel. But that is just yet another hyperblocks operation. We're not going to run through all of this, but once I click it, you can start to see the image on the right. Well, through each iteration, get a little bit blurrier. And one of the things that's fun about this is that ran 10 iterations in about a second, is you can play with how many iterations you want to blur something. You could also play with the strength of the filtering. So I have not yet added like a Gaussian blur here, but there's a way of doing that. But there are lots of other things that we could do. So sharpening is just blurring by a different kind of filter. I can actually clean up this map, that's fine. But to sharpen this image, I just use a different set of parameters. Same thing where I multiply our image essentially by this sharpen kernel. And what I get back is an image that looks the same, but now you can see is the lines are a little sharper. And so the next step that you could do is to take this further to do things like grayscale conversion. Then you can start to detect images, or excuse me, detect lines in images. And that it becomes the basis for a lot of other sort of computer vision style algorithms. So there are a few tricks and hyperblocks to thinking. So I first tried this if then else thing to protect against edges. And it turns out that if you can replace if then else with a min and max function, which are already hyperized, your speed increases like tenfold. And so I think there's also some fun lessons in here about thinking about data programming and array manipulation as its own thing, even sort of distinct from
I'll stop the torture.
Thank you.
Thank you, Michael. Can you post the or just start the project yourself?
Yeah.
Okay, so next up is Ken. And
right. So this one requires the camera, so I'm going to right. No. Sure. Oh, start my video? I don't know what that's about.
That's a big cookie.
What happened to it? Somehow the, oh, it's just on the wrong. Do people see this little red face over here?
There we go. Yep, now we got it.
Okay.
So if I lean towards my camera and click here, it recorded my face just now, 468 different 3D locations. And I could, you know, oh, I have to click the green flag it, but I could, you know, rotate it different ways and all this. And I could scale it up and so on. So, whoops, made it very tiny. So this is just using a pre-trained model that called face mesh that only works on faces, but could come up with all these coordinates, 3D coordinates for every point on your face. And I didn't do very much with it. I just sort of displayed them in a really simple way. But with these demos that are showing some 3D things, it might be fun to take this and combine it with that so that you really get a very accurate kind of 3D model of somebody's head. And that's pretty much what I wanted to show.
Can you show it rotating a little bit more? It's really
Oh, yeah, yeah. So let's see. You know, turn it this way, turn it that way.
And that's from a single snapshot?
A single what?
A single take, a single snapshot? A single picture?
Yeah, so yeah, it's just from a single picture. It'll come up with the 3D. You know, I could do it again just to prove it here.
Can you open your mouth really wide when you take the next picture? It looks like you're doing something different.
Well, I didn't hear the last question.
Or could you open your mouth when you're taking the picture?
Oh, sure.
So we can see that it's a different face.
There we go.
Wow.
Whoa.
It works. It works.
Good. Oh, I'll stop sharing.
Nice. So much 3D this year. So there's no one else lined up. So I will show another 3D project. This one I made a long time ago, but I've just realized that I never showed it. And I don't know if you played that game called Outrun ages ago. It was 3D by that time standards. And I investigated a little bit about how these games were made. And in particular, I looked up how Mario Kart was made, which looked really 3D to me at the time. And what they basically did is they took a 2D map of a racing track, and they would skew it this way, right? So basically they would slice it horizontally, and they would make each slice slightly larger, slightly wider, so as to fake a 3D perspective. And then they would rotate that map right before slicing it every time that you turned, right? So that would give you an impression of rotating in the plane. And I implemented that, and this is the result. This is the actual map that's being sliced in real time. And it's slow because of the screen sharing, but it's usually really fast. Now, adding sprites to compete with is another story. I wish it was faster. It is way faster when I'm not sharing my screen, but if I make it smaller, it's also faster. So I can, of course, go off track and show you a little lake that I made in here.
I think it's faster in presentation mode too, because it doesn't just highlight the blocks.
Oh, let's try that.
See if that changes anything. You still have a minute.
No, it's lower.
Interesting.
But I'll share the link and you can try it in your computers. You'll see it's faster than this. Okay, yeah, exactly. That's mode 7. So unless someone else has something else to show.
I could show something about decision trees if people want to see it.
I have the Madlibs to show.
Go ahead. Okay, so we have Brian Broll and Dan Garcia. So go ahead, Brian.
All right, so so another activity that we've been trying to make different various machine learning concepts, accessible to students where they can actually mess with the model and stuff itself. And one of these is, of course, like introducing decision trees, and we get into other sorts of models and things as well, including the find the minimum game and stuff like that. But anyway, for the decision tree activity, we actually have this algorithm or this block for building a decision tree given the labels, so then you can just visualize it after this one. I'm showing the solution here, but generally there's a embedded Parsons problem in here. Not the whole thing, because the whole thing is a little bit tricky, but this is basically a decision tree that was just learned on this synthetic Twitter data set. So trying to detect whether or not a Twitter account is a bot or a human account based off of some of the metadata about the account. So like the highest number of tweets per minute, if it's over 31, it says it's a bot. If there's no picture, then it starts going down this route over here. But it's kind of nice when you can start talking about interpretable machine learning, and interesting is we also have this example that's actually working on a real data set. So this is a data set that's a fishing data set. I have a link. Basically, then we can actually build the tree here on a subset of the data, and okay, maybe whoops, sorry, this is actually an old one. Name them. Yeah, it's sometimes tricky to keep them straight when there are so many different names. And sometimes I look at the timestamp. But anyway, here's a simple decision tree trained on a subset of this fishing data set using the features that they have. So if checking to see if these different properties are legitimate fishing or just suspicious. But anyway, that was pretty quick, and I feel like each of these is always a whirlwind when I'm trying to show something that has a lot of background and things like that, but hopefully it seemed at least mildly interesting, and I can post some links in the chat.
It was really interesting. I'm just wondering, where did you get the threshold of 31 tweets per minute? I thought it was pretty large.
So I simplified the tricky part is how do you figure out where to branch, like how do you slice the data. So the algorithm is actually really simple. At least that one is just look at all the different ways you could cut the data, and then pick the one that most cleanly separates the data. And you can use entropy or a measurement of entropy from math to actually quantify that. So 31 is just because there was one example. It just goes through the data and looks through all of the different ways you could cut it. So there was one data point that was 31. So it just oversimplified in the sense, or there are optimizations to make the ways to look at how to split the data faster, and you probably wouldn't use this one in practice because this one just enumerates all possibilities based off of what data is there. But with the smaller data sets that we're working with, it keeps the algorithm simple anyway, so that and we can kind of abstract away that portion. But anyway.
Thank you, Ryan.
Yeah,
so
no
Jadga has just spontaneously volunteered. So since Dan had already shown a couple of projects, I'll let Jadga jump in. So
hi. So everybody's just taking care of their kids, so I thought I'll just jump in and show a project, and then I'll be back at the wedding. So let me share my screen. The project that I wanted to show, I've already shown at this year's Robolot, so a few people might have already seen it. But I was experimenting a little bit with audio encryptions. So I watched a YouTube video, and there was this guy mentioning something about a famous DJ who once hid an image of himself in a tune or a song from him. So I thought, well, maybe we can do the same thing. And I tried it out, and we can read that out in Snap. So here's the one project that we built in the From Media Computation to Data Science course. So this is just tracking the frequency spectrum of my voice. So for example, I could sing with the different pitch, and then it's recording this. And then I thought, well, if I play a sound and hide information in it, I could just let this program display the thing. So how I did this is that I'm actually creating clones on different levels, and they play in a specific pitch. And then I can use that information to display videos. So this, what you just heard, was the sound that Alonso makes when you play it as a tune, and I'm just converting the pixel values of Alonso to the volume of the specific clone at that pitch, and so I can, in this way, I can display images as audio. No, I can display audios as images to also send information. That's my presentation. Thanks.
Nice. Really nice. Jadga, could you share a link to that project? And I think, well, we sort of have time for another one. Dan, do you want to jump in?
Yeah,
real quick?
I'll do this really fast, sure.
Okay.
So let me do that.
Well, we still have 3 minutes exactly. So.
Oh, perfect. Look at that. Here we go. Okay. Sharing and this one. So I got so excited, Jens, about this metaprogramming that I decided people who are part of the middle school curriculum might know that we have this Madlibs. And one of the activities is just to hard code your own Madlibs or to actually edit the program to make the Madlibs. And I realized you could have a Madlibs maker. So here's a friends Madlib where you put in 2 friends. It says friend 1 and friend 2. And it says, so the fun thing about Madlibs is there's a hidden sentence behind it. You don't know how they're going to use these words. I want Dan and also Brian at my birthday party. And the way I made this block is I typed make a party Madlibs using a template sentence with exactly 2 parameters in uppercase. So I want friend 1 and also friend 2 at my birthday party. And I ran this and I got this block. And this block just does this, join I want. So it finds the uppercase and puts it there, puts it in the middle. It finds this uppercase and puts it there. So this is hard-coded for exactly 2 parameters, but you can now make any one. So here's make hungry Madlibs. I want to eat fruit and veggies during the Super Bowl, and it made this block. And if I click it here, I want to eat apple and spinach during the Super Bowl. And the final one is SnapCon. The best talks were Talk 1 and certainly Talk 2. Boy, cannot wait to play those demos. And I'm going to make this, and you see the SnapCon block just appears. And I might say Jens's 3D program and Bernat's 3D program, because I like this thing. And the best part where Jens's 3D and certainly Bernat's 3D. So the kids don't have to actually learn how to edit the block to make their own Madlibs, which I think is really, really cool. And if I still have time, I want to show you this cool thing, which is I want to go on a soapbox for a second, which is I have students every single year think that if I have a list of numbers, if I have a list of numbers, this will delete that number. If I have a list of numbers, 5, 4, 3, 2, 1, they think this one deletes the 1, deletes the last thing, because this is actually supposed to be at. See here, insert thing at, you have the word number, the word at means the index. This implies you're deleting the actual element. So I think this should be delete at. That's a little soapbox. So I actually made reporter values of all these. I think a lot of folks have been using these to do some modifications of lists. How cool would it be to actually reporterify all of these? So I have add this to that, puts it at the end. Delete item this at that, reports a new block without that there. Delete all of, so these are different. This is the index, this is the element, delete the B's. Insert thing at 2, it puts it in the thing, replace item there, replaces it, and replace all this. This is not hard, and none of these use these to use. I want to keep them all functional, so each one of these uses like a keep or a map or something like this. So I think these should be what's here, and these should actually be part of a library. So let's move to like reporterify. Thanks.
Okay, that's going to be controversial. I like these blocks though. I don't know if I'd replace the imperative ones yet, but they should be somewhere, that's for sure. Okay, so thank you very much. Submissions on the site. Michael is asking me to remind folks of something, but I don't know. I don't know what that is. Do you want to speak up, Michael? Okay. In any case,
I'm wondering if is anybody going to gather up all the project URLs into one file? Something good.
Yeah, they are all going to be in the SnapCon 2022 collection, which is in the front page of the Snap site. And they are almost all of them in there, the ones I could put while moderating, and the rest are going to be there during the break.
Good.
Okay. So thank you very much for attending this session. It's been great again. I really love this session. I love seeing all of your projects and what people have been making in the last 6 months. I can't wait to see what you make in the next 6 months at Snapshot. And I will see you all after the break.
Thanks, everybody.
Thank you very much.
Looking forward to the
Thanks
keynote,
to all the
too.
presenters.
Wonderful.
Thanks, everyone.
Thank you, Bernat. That was awesome.
Thank you.